In this video, I'm going to show you how to write the formula for an ionic compound from the name. So I do recommend that you watch writing the formula of ionic compounds first. That will be my assumption, is that you have looked at that part. And then this would be a follow-up video to that. So we were working in the previous video on when we know the charges, writing the formula of the compound, and then naming that compound. And so this is working backwards. This is when we would be given the name and then getting to the formula of the compound. And you're going to see that there's a lot of overlap between the two processes. So if you have the name, the first thing you have to do is figure out what your ions are. So you have to identify the cation and the anion. Now remember, in names and in formulas, it's the cation first, and then it's followed by the anion. And if we want to even make it more general than that, it will be your metal, which is formed by cations, followed by your anions, which is going to be your nonmetals. Now, there may be polyatomic ions in here, which are also made of nonmetals. So they could also be involved. And like I mentioned in the previous video, the best thing you can do is start memorizing those basic polyatomic ions that I recommended. And once you do that, it really will make working with polyatomic ions easier. Maybe not easy, but easier. So the first thing we do is we're going to identify the cation and the anion, and we have to figure out their charges. So that sounds a lot like what we were doing before. You can remember, just as a side note, for any of the metals that have a variable charge, and what that means is they can form more than one ion. So let me give you examples of that. That would be like an iron 2+, which would be called iron Roman numeral 2, or iron can form a 3+, which is an iron Roman numeral 3. 3. And so that's just saying that the Roman numerals will be in the name, and that will tell us the charge. So then after that, this looks so much like what we were doing. You're going to find your ions, you're going to balance the charge, and you're going to write the formula, making sure that the charge is equal to 0, the positive and negative. That's what balancing the charges mean, is that you're going to make sure that you have the same number of positive charge as you do negative. So honestly, this is very similar to what we were doing before, except in the previous video, I gave you the ions, and then we got the formula from that. In this case, we're going to have the name, so we'll figure out the ions, and then we'll write the formula. So again, if you're like, whoa, I recommend you go back to the previous video and review that, practice that, and then come to this one. So let me find some names of compounds that I want to write the formulas for. Now, I don't have a periodic table on this particular slide, so I'm going to be from memory, thinking about the main group charges that we predict. So it could possibly help you to have a periodic table near you where you've written the charges predicted for the main group elements. So let's say I started with barium chloride. So this is the name. In fact, I want to, just one second, I'm going to make columns for us so you will connect what I'm talking about. So I'm going to write the name for us. Then we are going to figure out the ions. And then we're going to write from the ions the formula of the compound. Figuring out the ions is kind of like the work in a math problem. Like that's what we have to do. We have to figure that out to go from name to formula of a compound. You have to figure out the ions. Okay, so I said barium chloride. Let's do that one. So if you look on the periodic table, barium is in group 2A, the alkaline earth metals, so it is a 2+. Chloride ions, remember in the names, the anions turn, the chlorine is the element, but the anions use the IDE. So you'd look at chlorine, and it's a halogen in group 7A, so it's a Cl negative. Now this is what should seem familiar. So the charges aren't the same here, so I can do the crossover. So for barium, I'm going to need 1. And for chloride, I'm going to need 2. So I need 1 barium and 2 chlorides. So that's going from the name barium chloride to the formula. So you have to get the ions in there. All right, let's try another one. This time I'm going to do copper 2. Let's see, what do I want to do copper 2 with? Let's do copper 2. I'm trying to think of a polyatomic ion, sorry. At some point we run out of, let's do copper 2 sulfate carbonate. Now, if you get this name, what I want you to try to start remembering as you're practicing is that ATE endings are going to be connected with a polyatomic ion. Okay, so ATE is not going to be carbon. I know you see the word carbon, but ATE at the end is a polyatomic ion. So we know that the copper is a 2+, because the Roman numeral tells me the charge. And then carbonate, you would have either memorized or you would have looked on a table, and carbonate is a CO3, 2 negative. So then what you would do is now to get the formula, you have to make the charges equal 0. So you notice that this is a 2+ and this is a 2-. And anytime you have a 2+, not 2+, anytime the numbers are the same, so 2+, 2-, you know that it's a 1-to-1 ratio. So we would write 1 copper, which would just be a Cu, and 1 carbonate, which would be CO3. So that's copper 2 carbonate. Okay, so let's try another one. And that just made me think of something else that I want to show you. So on the next page, I'm going to show you one other thing. It has to do with the name of formulas. So I'll show you on the next slide. Let's do a couple more of these. So let's do sodium. Sodium, and what do we want to put sodium with? How about phosphorus? So sodium phosphide. Now, IDE usually means you're just talking about the element, Okay, so this is with phosphorus, because remember the nonmetals change their ending to IDE. There are two polyatomic ions that end in IDE. And so, I can't say that all polyatomic ions end in ATE or ITE, because you have these two that end in IDE. But if you really look at like hydroxide, it doesn't just look like hydrogen, it looks like hydrogen and oxygen. So I hope that as you start practicing, you wouldn't think that was oxygen or just hydrogen. So oxygen by itself would just be oxide. And hydrogen, which can be a positive or a negative, if it was a negative, it would just be hydride. So maybe you could see that. And then cyanide, that doesn't have carbon or nitrogen just in it. So I'm hoping that if you saw those, you could kind of recognize them as a polyatomic ions. And then otherwise, polyatomic ions end in ATE, 8, or ITE, 8. And then everything else with IDE is just a nonmetal. So if I saw sodium phosphide as my name, sodium is in the first group of elements, so it has a 1+ charge. And phosphide is from phosphorus, and it's in group 5A, and they have a 3 negative. So if I do the crossover, if I think, because they're not the same, so if I look at the crossover, sodium, you're going to need 3 of them, because phosphide has a 3 charge. So to balance it, I'm going to need 3 sodiums. And then the phosphorus, sodium only has a 1, so it only takes 1 phosphorus. So let's do another one with a polyatomic ion. Let's do iron 3 hydroxide. So to get the formula, iron with a Roman numeral 3 means iron with a 3 positive. Hydroxide, normally I see IDE and I think of a nonmetal, but hydroxide I have up on top is a polyatomic ion. It's OH with a negative. So remember, on polyatomic ions, we're not so interested in the OH, like that's part of it, but when we're putting it together, we need to look at the charge. So for the iron, you'd look up here, and hydroxide only has a 1 negative, so we just need 1 iron. And then to find the hydroxide, we look and see what iron has. It's crossover, we look at the others. And iron has a 3, so it's going to take 3 hydroxides. So since it takes more than 1, we have to put a parentheses, because we need 3 of those, and put the 3 to the outside. Okay, so let's try another one. So I want to do zinc bromide. Okay, so zinc is not in the main group. It's a transition metal. So if you got this like on a test or on a worksheet and you went to the periodic table, it was not in one of the columns that we can predict. But then if you look to the table on transition elements that I'm going to give you, you can find zinc. And you'll notice that zinc only has a 2+. So that's why, even though it's a transition metal, it does not have a Roman numeral because it only has 1 cation. And so the only ones that have Roman numerals are the ones that have more than 1 cation. So even though it's a transition metal, it does not have a Roman numeral because it can only have a 2 plus. So to find out this one, you really would have to use that table of the common transition metals that I am providing for you on the exam. Before the exam, you could either look in your textbook, look in the class presentation notes, because I have that table, or you can look at the exam 2 packet, where it is a part of that packet, which you can find in Canvas. So you would have to have that as a resource, I think. And then bromine is a halogen in group 7A, and so I can predict that. So again, they're not the same charge, so I can use the crossover. So for zinc, I will need 1. So I need 1 zinc for this to balance. And then bromide, let's see. I look back, and that has a 2. So the bromide, I will need 2 of them to balance. Now, there is, and I think this was on your worksheet, there's 2 common positive, so cations that are polyatomic ions. There is, I'll write it down here on the bottom, there's ammonium, which is a formula NH4 with a positive 1. And then there's hydronium. Now, in this chapter, we really don't see hydronium as a part of these ionic compounds. We see hydronium a lot in, I think for us, it's chapter 9, when we talk about acids and bases. We'll see hydronium. It's part of the acids. But ammonium we could see. So I'm going to put an example here on how we might use it. So let's say we see ammonium, and then I'm going to put it with 2 polyatomic ions just to give us an example. So ammonium nitrate. So the ion for ammonium I just wrote underneath is NH4 plus. Now if you see nitrate, look, this is ATE. And remember, I mentioned if you have ATE or ITE, you're a polyatomic ion. And so nitrate is NO3 with a negative 1. Now I'm going to write up here nitride, which is IDE. That would be with nitrogen. So that's nitrogen, which is in group 5A, so it would have a 3 minus. So these are the kind of things that can trip us up when we're first learning. Don't be discouraged. It's just part of learning this, how everything is connected, and it takes practice and a little bit of memorization. So if at first you're getting things confused, don't be discouraged. You're just learning it. Like there's just these subtle differences that once you learn it will feel obvious, but when you're beginning the learning process, it's not obvious. So don't be discouraged if you mix things up. Just keep practicing. You will get better at it if you practice. If you don't practice, you won't get better at it. That's how life is. All right, so let's look at this one. Now, what I know with polyatomic ions, there's all these letters and numbers, but remember that's just a part of the group. And so that's important. We have to put them in our formula, but that's not what's going to determine how many we need of each. What you want to look at is these charges. So this is a +1 and this is a -1. And so if you recall from the previous video, if the positive and the negative have the same number, you only need 1 of each. So I need 1 ammonium, so I write NH4. And I need 1 nitrate, so right next to it, I write NO3. No parentheses, no spaces. And at first, when you're first learning, it just looks like a bunch of letters. But once you know what ammonium and nitrate is, that's what you see when you look at it. All right, now I mentioned there was one thing I wanted to show you. This probably goes better with the first video than this video, but this is when it came into my mind. So the thing I wanted to show you is what happens when you get a formula like and you have to come up with the name. And so we know that you name ionic compounds by naming the ions. And so I know this is iron, and I know this is chloride. But I have to remember iron can be a 2+ or a 3+. Right, so iron has to have a Roman numeral. And so what do you do when you have a formula and you're like, what's the Roman numeral? Well, here's what you do. You look at how many of the metals, or non-metals, sorry, the anions, it took to balance it. So it takes 2 chlorine to balance that iron. So that iron must be iron 2. If I had this, okay, it takes 3. So this must be an iron 3 and then a chloride. Because remember, when you're naming ionic compounds, you're just naming the 2 ions, not how many are there or anything like that, just the 2 ions. So let's do another one. What if I had copper with nitrate? Now, copper is another one that can come in 2 charges. And when you name it, you have to know what charge it is. So even with polyatomic ions, to know if copper is a 1 or a 2, I can look over. It takes 2 nitrates to balance that copper. So that means copper must be a charge of 2 because it takes 2 of the anions to balance it. And then NO3, it has a name of nitrate. So remember, the Roman numeral is not telling you how many you use, it's telling you what the charge is. And it's like in this step, it's like you're reversing the crossover method. So you're using what the metal is with to figure out what its charge must be. Now I have one more. Now, in this case, we know copper can be a 1 or a 2, and you might just quickly say, okay, copper is a 1 because it only takes 1 oxygen, which isn't, that it shows that you're starting to kind of understand, but think back. If you have 1 of each element, what that really means is not that they both have a 1+ and a 1-. But what it really means is that their number is the same. So if you have an element that is that has more than 1 charge and it is in a 1-to-1 ratio, you have to look at the charge, not just how many, but the charge of this one. So oxygens are in 2 negatives. So if you have 1 of each, this copper must be a 2 positive. Now, I didn't do all of these examples that I've been working on, which came into my mind at this point, are the cations that can have more than 1 possible charge. You don't have to think this hard if that's not true. For example, if I have MgO, right? Magnesium can only have a 2 plus. It doesn't have Roman numerals. So this is just called magnesium oxide. Or if I have Na2SO4, I don't have to think that hard. Sodium can only have one charge. So this is just sodium and then sulfate. Or if I had Al2, trying to think of one, CO3, 3, I don't have to think this hard. You just name the two ions. So it's just aluminum carbonate. Okay. The reason I have to think so hard on these examples up here is because in each case, I need to figure out the Roman numeral because that's a part of the name. When you don't have to figure out the Roman numeral, all you have to do is name the two ions that are present. Okay, so, which is what we did really in the first video. We just named the two ions that are present, but I didn't do any examples where we had the formula and you didn't know which ion it was. And so I wanted to show you a couple examples of that. All right, again, don't get discouraged about writing formulas and the names. It is important that you know how to do it, but you just need to really keep practicing. And if you have any problems or examples you can't do, please feel free to reach out to me or to one of the tutors and we can work through it. I can give you some more examples. We can see where the little catch is. I will tell you, especially with polyatomic ions, the more familiar you are, the less struggle it is. So keep working at it and let me know when you have questions.